Hello, friends. Today I will talk about an important area of production support, namely root cause analysis. So, what is root cause analysis and why is it important? A root cause is the fundamental or an underlying reason why a production issue occurs. And an immediate fix or a workaround, which we often do in production issues, can resolve the immediate issue at hand, but it does not fix the issue from root. So there is a danger of the issue repeating. So let me explain with an example. For instance, if a computer crashes, we may simply reboot it and it will come up again. That is the fix. However, why did the computer crash in the first place? Was there some program which was consuming too much system resources? That is, and if we identify that yes, program XYZ consumed too much resources which caused the program to crash or rather the computer to crash, then that is the root cause. So why are root cause important? Like I said, that until an issue is fixed from a root cause, it can repeat. So in this case, until we remove the program or optimize it, it will cause the computer to repeatedly crash. So such repetitive occurrence in production require repetitive effort to fix it immediately, like which may involve a system restart, for instance, and hence there is a recurring cost. And so if we fix an issue from the root, it will take some investment initially, but then we will save this recurring cost. And so root cause analysis is very important because it leads to cost saving. What are some of the common root causes? First one is change related root causes. So there is a production deployment. This deployment has a unintended effect or rather an unintended effect of causing a production issue. This can cause some existing program to fail or some environment to crash. So these kind of issues can arise from a change. Then the another example is data issue. For instance, we load a file which we receive from an upstream system. However, this file has bad data. For example, there is a date field and instead of the 12 in the month, it has 13 in the month, which is an invalid month, and hence the program fails. Then we can also have a system overload or performance issues. There is too much capacity being used. There is too much CPU, memory. Some parameter stresses the system and it fails. There could be some hidden code bug which surfaces due to a data condition or environment condition. There can be contention between two concurrent or more concurrent programs. There can be scheduling issues. Then we can even have false positives where there is nothing wrong essentially in production, but some alerting wrongly thinks that there is an issue. So this could be a case of too sensitive threshold or too low a threshold for alerting. So how do we identify root cause? It's a bit like detective work. Telecom always used to say that we need to capture proper data, not exactly in these words, and then make a theory according to the data rather than vice versa. So it's identifying root cause is also a bit like detective work. We need proper data points, we need proper logging of errors of the system. We need to identify trends, patterns, these kind of things, and from there we will be able to identify the root cause. Common solutions tied to the root causes which I had mentioned, there are various solutions. For instance, if a system has issues pertaining to overutilization, we could add capacity, we could make the system more scalable, we could build more resilient code for code issues, or we could have logics like retries that the system, if a system can be made to autocorrect, or otherwise there can be proper exception handling so that it anticipates a few error conditions and doesn't really fail for those, just logs an error. Then having more control changed, better change management, better change oversight also helps. Testing is an important thing. If we catch our errors in a test environment rather than having them leak through to production, we will be in a better shape. Performance tuning can also help in preventing failures due to performance issues. We can sometimes make scheduling changes to prevent contention and other such things. So these are some of the common solutions. So lastly, I'll just conclude with some ending notes. First of all, my disclaimer, the opinions expressed here are my own and not of any organization or entity I am part of or have been part of. I always welcome feedback and suggestions. Thank you everyone for watching my video.